Here we are going to discuss question number 3 in this assignment 4, MMTH 105. It talks about applying rules of indices to simplify 4 terms. So here's an example of A. Now, the rule we're going to apply here for number 4A is the rule. When you multiply indices, and the bases are the same. For example, let's say you have ax raised to the n. So x is the base, n is the exponent, and a is the coefficient. When you are multiplying indices that have the same base, let's say x, although the coefficients can be different, let's say b, and the exponents are different. Once the bases are the same, what you simply do is to multiply the coefficients, maintain the base, and you add the exponents. Another word for exponents is powers. You add the exponents. Okay? So, in this example, all we do is simply multiply 4 5s are 20, and we add 7 plus 2, or 2 plus 7, to give us 20x raised up to the exponent 9. 2 plus 7 is 9. Continue with B. It says 24x to the 7 divided by 8x to the 5. Conversely, when you are dividing exponents or indices, okay, the rules of indices, when you are dividing and the bases are the same, you divide the coefficients. So that'll be A divided by B. You maintain the base. Once the bases are the same, you maintain it, but you subtract the exponents. So the dividend, ax to the n, coefficient has to be divided by the divisor coefficients, and the exponent of the dividend have to be subtracted by the exponent of the divisor. So it's n minus n. So in this case, we've got to divide 32 by 2. So 32 divided by 2 will give us 16. Maintain the x. But what we do now, we subtract the powers, we subtract the coefficient, the exponents, sorry, because we divided the coefficients already. So we subtract the exponents, subtract the powers. 9 minus 3 will give us 6. Powers is an easier word to mention than exponent. So you can say subtract the powers. Here, for part C, is similar to part B. We are dividing. However, the division is represented differently. The division is represented as a fraction. So the dividend is in the numerator That will be ax to the n in our rules. And the divisor is in the denominator, because in some cases, the term can be represented that way. So the same rule applies. So basically, we divide 21 by 3. 21 divided by 3 is 7. And we subtract the powers. 7 subtract 4 will give us 3. So 21 divided by 3 is 7. 7 subtract 4 is 3. Divide the coefficient, subtract the power. Here, this one, they call this one powers raised. That's how this one is normally called. Powers raised. Basically, you can see the appearance of only one base and one exponent, well, 2 exponents. 5 is the exponent. And outside of the bracket, there's another exponent. Okay, let's use brackets of local dot equations. Okay. So that we can raise ax to the n, the entire ax to the n have to be raised to another exponent. Let's call it the same m. So in such a case, what you do now is you raise all what's inside the bracket by that exponent. So a is raised to the m, and x to the n is raised to the m. So basically, you are multiplying n by m. So that will be the answer, the rule. So basically, in this case, 4 will be raised to 3. Times x will be raised to the 5 times 3. Multiply the exponents. And 4 raised to the 3, that's 4. Times 4. Times 4. Okay. 5x to the 5 raised to the 5x to the 5. That's x to the 5 times x to the 5 times x to the 5. So this is why, you know, when 4 was 16 by 4, it was 64. And x to the 5 times x to the 5 times x to the 5 brings us to the first rule. That'll be 5 plus 5 plus 5. That will be 15. So this is why, though, it is simplified to 5 times 15. You multiply the powers. That's why this rule, you simply multiply the exponents. So that's what you do for this question.